today's lesson we'll be looking at chemistry 1502. The topic for today will be looking at alkenes as our topic, lesson 102. Let us start. Our next homologous series is alkenes, but we are going to integrate the skeletal structures, of which we should have started with the alkanes, but it doesn't matter, it's no problem. This lesson video will also teach you how to use skeletal structure, but also the different types of structures. The skeletal structure was covered also. So alkenes is one of the homologous series that we have. We can say it's second from the basic of our alkenes, and we'll also be looking at the differences. The difference is that you can clearly see that the ending letters is E and E, and the general formula is simply CnH2n. You can clearly see the difference. We have two differences now. Now we look at the first one. You should understand that under alkenes we don't have methane. The reason why, let me show you. In order for you to understand this, let us look at the next one, which is ethene. Ethene, its structural formula will be like this. And by the way, this is an unsaturated compound. Unsaturated means it has multiple bonds between carbon and carbon. So in this case, the reason why we cannot have methane, remember we need this pi bond between two carbons. But we know that methane or meth simply has one carbon. So we cannot represent the double bond between the two carbons. So we don't have methane. Instead, we start with ethene. Now let us look at ethene. You can see ethene, it has double bonds compared to ethane. Going back to ethane, we had something like this. You can see the differences. The molecular formula of ethene is C2H4. Molecular formula of ethane will be, it's actually C2H6. So you can see the number of hydrogens have been reduced. Using this general equation, you can see we have two carbons, H2 multiplied by 2, we are going to get 4, which is this one. Going to propene, as we continue with this lesson series, we'll also be looking at IUPAC name. It is very important to indicate where we find this double bond. It's actually not a double bond, it's a single bond here. Molecular formula, you can use this equation and you will find it. It's basically C3, then 2 multiplied by 3, we'll get 6. The next one will be butene. Let us address the position of that double bond. Suppose we want to draw but to in. This simply represents the position of our double bond. Then when you draw this, we are going to have C, 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 then it's 1, 2, you're going to have it here. If we were to draw but 1 in, then our double bond would be here. And also, it is very important to know where we start counting our carbons, but we'll deal with that once we get to the IUPAC name. So put 1 in, if we were to have put 1 in, the pi bond would be here or here. Doesn't matter if you count from this direction or this direction. Then you can see if we want the molecular formula, it would be C4. Remember that for butane, but we have 4 carbons. Then you can use that equation. It will be 2 multiplied by 4. Then we're going to have 8. Before we continue any further, looking at the skeletal structure of this, we are going to have 2, 3, 4. We have 1, 2, 3, 4 carbons, and then the double bond is between carbon number 3 and it was actually, there's a small mistake here. If we want to write, put 2 in, but it's actually correct, because if you count, we have 1, 2, 3, 4. Even if you count this side, it's 1, 2, between 2 and 3. So it is actually correct. We have 1, 2, 3, 4. So our double bond will be here. Remember, this homologous series is unsaturated. Or let us write pent 1 in. So we have 1, 2, 3, 4, 5. Our double bond will be here. Then you can simply fill in everything. The skeletal structure, it's 2, 3, 4, 5, and then it will be here. Molecular formula will be C5H10. Simply 2 multiplied by. Then we can go on to hexene, hex 1 in or hex 3 in. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3. Then we have our double bond here. Then we can go ahead and fill in everything. Even if you count this side, it's 1, 2, 3. And you should understand that, let's say we wanted to draw hex 4 in. Just know that we don't have something like this. Reason why, I know that you are still going to cover this in the IUPAC naming. Okay, this is 1, 2, 3, 4. It means that we are going to have this. But you can check that if we count from left to right and from right to left, we have 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6. You can see that the double bond is between 4 and 5, but when you count from here, it's between 2 and 3. So we always pick the lowest number, or we always look at the position where it is closest to the ends of our carbons or our starting carbons. So instead of having 4 hexene or hex 4 in, we are going to have 2 hex in or hex 2 in. So one of the things that we'll be covering in IUPAC naming. The next one is hept 2 in or heptene. If it's written heptene, it simply means that the position is on the first carbon. So we are going to have our double bond here. Then we can just fill in everything. I believe you can see how we do this. And then we have C7H14. Skeletal structure of this, we have something like this: 2, 3, 4, 5, 6, 7. then the double bond would actually be between 2 and 3. For you not to get confused, if we were to draw hebt 1 in, it simply means that the double bond would be here. Then on the skeletal structure it would be here. Oct, let's say 2 or let's say 3 in. Octene, so we are going to have 8 carbons, and then we have 1, 2, 3, and you can see here, especially multiple choice questions, they will give you a structure like this, and then they ask you if it is octene, oct 3 in, or it's, let's count from here, it's 1, 2, 3, 4, 5, 6, 7, 8, or oct 5 in. Then you should know that you always pick the lowest number. Then for this, you are going to have C8H16. Now I believe you can see how we do this, and the first homologous series, which is alkanes, they actually covered, that lesson video covered most of the basics that we find in this homologous series. So in the next lesson video, we'll be looking at the next homologous series, which is alkyne. So stay tuned, make sure you watch that lesson video. This is Mahula SJ, thank you very much.